Good day. This is another round of graphing notes related to Le Chatelier's principle. So I think it's handy in relation to the graphing video we just watched, but it'll also be handy when we get down to the math of equilibrium later on in the second half of this unit. So we're going to look at temperature changes, and we'll look at other stresses as well. And in each case, there's one example that's done and one example that you can work out for yourself. So let's look at temperature change. It says our stress as the temperature is increased at 2 minutes. So we're saying what's happening there? Well, we see this is an endothermic reaction in the forward direction. We know increase in temperature, we want to use up that extra energy. So it's going to shift to the right. When it shifts to the right, we're going to make more NO2. So it goes up, and we're going to use up N2O4 to get there. So in order to make NO2, we got to use that up. So that's why the N2O4 drops and the NO2 increases. We have a 2-to-1 ratio. Stoichiometry says NO2, every time we make it used up half as much N2O4. We know we're at a new equilibrium because the graph is flat. We also know we have a different value of KEQ. In fact, it'll be higher because we now have more NO2 than we used to, and we have less N2O4 than we used to. So our products to reactants, that ratio goes up. So then it says, hey, you can try it out for a different stress, and that sounds like great fun. Now let's look at concentration here somewhere. Okay. So we have an equilibrium here, and it says NO2 is injected into our container. We know the NO2 has gone up. We got to use up that NO2, so it's going to shift to the left. And it's going to make more N2O4 and use up some of that NO2. So what we see is a concentration effect. One thing will spike or one thing will drop. In this case, the NO2 increased or spiked because it was injected. Now the N2O4 is going to curve up, and the NO2 will curve down as we arrive at a new equilibrium. When the NO2 comes down, when it's a concentration stress, it is not allowed to go below its original amount. That will not happen. This goes down, this goes up by a factor of 1/2. Now that ratio, when we get here, a boom to boom, compared to this, according to the KXQ expression, does not change. So that will still stay the same. That's a concentration stress. All right, let's see up here as we have a pressure change. And so it says the volume of the container is decreased suddenly. That decrease means there's a pressure increase. And so in this case, we see both of the pressures spike. Now we have to look at equilibrium. These things have both gone up. There's 2 moles of gas here. There's 1 mole of gas there. So it favors the direction of making N2O4. The equilibrium is going to shift to the left. So the N2O4 should go up and the NO2 should drop. Let's check out our graph as we go along. So there's our N2O4 going up, and then there's our NO2 going down. Now, the starting point for the N2O4 going up was here, and the starting point for the NO2 going down was here, and that drop was twice as much because we have a 2-to-1 ratio. Every time 2 of these react, they make 1 of those. So I hope this gives you a pretty good idea of how to deal with these graphs. Again, we haven't got into the math of it too heavily. That will be coming up later.